we are moving into the real life application of systems of equations, and that's what businesses use and chemists use it to apply to help create mixtures or maximize kind of profit or see how much they need to sell to break even. And here's a business application. When we solve a system with a business cost and sales, it's their break even point. That means when their cost is equal to how much they sold. Their cost to make stuff is equal to how much they sold. So there's two equal equations. It's not really a system. A system is where, you say, it's kind of a system, but we don't set it up the way a system is. We set it up like this. Total cost to make equals how much they sell. Like one main equation with variables on both sides. So if a fashion designer makes and sells hats, each hat costs $5.50 to make, and she spends $1,400 to advertise her hats. She sells them for $12.50. How many does she need to sell to break even? So I need a cost side and a selling side. So my cost for each hat, let X equal your hat. My cost or her cost is $5.50 for each hat. That's how much she has to spend to buy the hat. Plus she's advertising. So she also has $1,400 that she needs to spend to advertise her hats. That's her total cost as the business owner. She wants to break even. That means she wants to equal the sales of her hat. So what she sells her hats for is $12.50 for each hat. And this will tell us how much she needs to sell just to pay for her cost. So we could go ahead and minus 550x. Remember, you move the smallest variable first. And 1250 take away 550 is 7. So 1,400 is equal to 7 times the hats. And then you divide by 7 and you get 200 equals x. But you need to connect that to the real life application we're talking about. That means she needs to sell 200 hats to break even. And those of you that are on a high school sport, if you're not just doing like a booster club sport, they have that goal for your fundraisers that they do. Like if they're like, I want you to sell at least, like for football, like at least 10 cards or 12 boxes of cookie dough. They do that because they want their cost to support all of their student athletes to at least equal how much was paid for during registration process. Okay, let's say a puzzle expert wrote a new Sudoku puzzle book. His initial costs are $864. Binding and packaging each book cost 80 cents a book. How many, if the price of the book is $2, how many does this author need to sell to break even? So we want our cost to equal how much we sell. That's always our goal. Cost equals what they sell. So what it costs the author is, well, let's say X equal book. So it cost them 80 cents each book, so 0.80 times X, plus it cost them $864 for whatever else the author is paying for. Maybe it's the running cost to keep the company running or the printing machines running. And we want that to equal how much he's selling it for each book. So he's selling the book for $2, so 2x. How many books to become break even? No profit, you just want to break even. So I'll move my 0.80x because that's the smaller one. And you get 864 equals 2 minus 0.80 is 1.2. Divide 864 divided by 1.2 is 720. That is a lot. He needs to sell 720 books in order to break even. Okay, so that's happens all the time. With all retail, it happens all the time. This business application. Then we can get to our science application, and this is more chemistry involved. But when you create mixtures, you want to make sure to write percentages as a decimal. Here's where I messed up the last time. The first equation is always x plus y equals whatever kind of total amount you want at the end. So this blank is a total. So it's going to say you want a total of 20 milliliters, or you want a total of 100 milliliters, or something like that. It's going to give you some kind of total. The second equation is definitely the percentage equation. So you have no percentages in your first equation. The second one you do. So it's going to be whatever the percent is times x plus whatever the percent is times y equals, now this is where last time I wrote the total percent, but you have to times that percent by the total amount of mixture you're getting. So the total times the percent. And you'll see that as we process through this here. Okay. So the first example. A dairy owner produces low-fat milk that contains 1% fat and whole milk that contains 3.5% fat. How many gallons of each should be combined to make 100 gallons of 2% fat milk? So I'm going to let x equal 1% and let y equal 3.5%. Okay, and then what we're going to do is you always have your total, so x plus y equals, I want a total of 100 gallons, so x plus y equals 100. And the second one, that's why we were messing this up the last time, because I forgot to times the total 2% by how many gallons I wanted. This is going to be 0.01x. How did I get 0.01? Because it's 1%. Okay? Plus 3.5% would be 0.035y equals, I want 2%, so 0.02, I definitely want 2%. However, I want 100 gallons of 2%, so you times that by the 100. And boy, oh boy, this is where it's like, what strategy do you want to use? Both, you could substitute, or you could use linear combination. Both of them will be completely effective. Do you guys know how to get rid of a decimal if you don't love the decimal? Do you know what you can do? Like if I had 0.04x plus 0.2y equals 7, do you know how to get rid of your decimals? Ben? Yeah, that won't help us much though. You could, but it definitely would make me feel even more stressed out to see it as a fraction. If you, and we did this very briefly in 7th grade, if you times everything through by the highest among decimal spots, it will get rid of it, okay? This is 10/100 is my biggest. So if I times everything through by 100, then this would turn to 4x plus 20y equals 700. And that just moves the decimal over. Timesing by a power of 10 just moves decimals. You could do that if you want. I'm going to choose 2 times the top by negative 0.01. And it's going to be weird, but I can do it. Because I have my calculator, and I'm going to be so careful, and my calculator is not going to steer me wrong. So this would be negative 0.01x plus a negative 0.01y equals negative 0.01 times 100 is negative 1. Hey, and guess what else I need to do? I need to know what the heck 0.02 times 100 is? Oh, I know. It's going to be 2. This is going to turn to 2. I don't know how I'm going to just kind of rewrite that down here. And then we can combine it. Cancel. Negative 0.01 plus 0.035 is 0.025y equals, negative 1 plus 2 is 1, divided by 0.025 is 40. Oofta, that's a lot of decimals. You can turn your decimals to whole numbers if the decimal stresses you out. Then that means I need 40 gallons of my 3.5% whole milk. And to find out how much 1% I need, I would go 100, take away 40, because I want 100 total gallons. So I need 60 gallons of 1%. Okay, 40 gallons, this is the whole milk. All right, so that definitely gets a little bit tricky with those decimal situations. The key point here, you have to remember when you find that final percent, you have to times it by the total amount that it wanted on the first equation, okay? We're just going to set up the other one. We're not going to go through solving since it does take a long time. One anti-freeze solution is 20% alcohol. Another one is 12% alcohol. How many liters of each solution should be combined to make 15 liters of antifreeze that's 18% alcohol? So the first one's always my total. X plus Y, I want it to be 15 total liters. And why don't I define my variable? X is 20%, Y is 12. Then, I need to do my percentage equation, and that's where it kind of messes kids up. So X is 20%, so 0.2X plus Y is 12%, 0.12Y. And then I have a final percentage of 18, so 0.18, but it's not just 0.18, it's 18% of the total gallons. I need that total gallons of 15. And then you would figure that out and use substitution or elimination. Both are effective strategies for that one.